The heritage listed Waddamanna Power Station was completed in 1918 and serviced Hobart and Launceston to 1965. It was then taken over by the more powerful and higher dropped Waddamanna Power Station. Pictured here is one of two diversion canals which takes water from the Shannon River from the Great Lake to lead and land in the Penstock Lagoon. Penstock Lagoon supplied water to the Waddamanna Power Station. These canals were dug with shovels and wheelbarrows, trees cut down with axes and dragged away with bullock teams. The Penstock Lagoon, which is some 300 metres higher than the Waddamanna Power Station, is no longer used to supply water to the closed power station. It's now used for recreation, fishing, camping and general enjoyment. The Waddamanna Power Station started as a private enterprise with investors but ran into financial difficulties, so was taken over by the Tasmanian government in 1918. It started off with 2 turbines and it was expanded to Waddamanna A and then also to Waddamanna B, eventually leading to a total of about 11 turbines.
How this all came about, this was the biggest hydro power station in Australia when it was built. It wasn't the first one. The first one was Duck Reach in Launceston, which is still there as a museum now in the Cataract Court. How this all came about, just come over here to did you drive past Great Lake?
Yes, we did, yep.
That's pretty unusual. That's in the Australian context, that it's a naturally occurring body of water at over 1,000 metres above sea level.
1,000 metres above sea level. Wow.
It's just over 1,000 metres. It is drained by the Shannon River, which flows to the south. Arthur's Lake was 2 small lakes. They dammed it to make one big lake, and they now pump water from Arthur's Lake up over a small range of hills and drop it into Great Lake, so it's a top up to Great Lake.
Just had a brief from Mick, and now we're going to check out the hydro station. Coming into, wow, there's all the switchboards, the turbines. With water supplied from the Penstock Lagoon some 300 metres above, a powerful jet of water spins this turbine connected with a very thick shaft to this massive alternator supplying Tasmania renewable power. Water comes in through this pipe, and then this mechanism here is the governor that controls the amount of water that squirts through the nozzle by putting a needle down the middle of it, which progressively gets thicker, slows down the water flow, and so controls the speed of the turbine. Otherwise the turbine will go too fast and it may blow apart. This is what they look like when they're not opened, and you can see there's quite a few turbines here. A massive control valve here. This is a model turbine. The water flow comes through, hits the turbine, and there's a control here that controls the speed of the turbine, and that will then show how many volts we're getting. So if I press start, so if I open it right up, we're producing 20 volts, and the turbine's spinning very quickly. And if I start to close it off, the turbine will slow down and the volts will drop again. A 30-ton overhead crane is used for maintenance work and also for installation of the massive turbines. Probably an hour and a half here at this amazing power station. These first two are the first two generators, and thereafter you'll see the ones with the higher pipes up top of the water coming in from the top and not underneath. They've been added later on, another 2, 4, 6, another 7 generators. There's a total of 9 generators here. Totally renewable energy. Massive shafts to make that water power turn into electricity. This is the Tower Race channel, which gets rid of the water, which goes back into the Ouse River, I believe. And there's the power substation to distribute the power. And behind there now we're seeing windmills, modern technology, topping up Tassie's hydro, going through the same substation. So why was the Waddamanna Power Station closed? It had a drop of just 300 metres rather than the Powhatan, which has a drop of 835 metres, thus getting much more bang for your buck from this massive drop of water from the Great Lake. When driving around Great Lake, we appreciated just how large it was, 176 square kilometres. So we're on a lookout above the Great Lake, and this just gives you an idea how big it is. We've been driving for probably 45 minutes along the shores of this lake. That's how large it is. The Powhatan Power Station has a drop of 835 metres compared to Waddamanna at 300 metres. It thus supplies 2.5 times the value or power out of the water compared to Waddamanna. The Powhatan Power Station is built underground, and once it's had the water through its turbines, the water travels through a large underground tunnel to a canal leading to a reservoir. There, that water is used for irrigation for the local farms. Looking down from the head race, we can see the water exiting the tunnel, which has come via the turbine through a tunnel to this canal leading to the dam where the water is reused for irrigating farms.